Okay, so I've got two identical 10 kilogram spheres, okay, attached to a light rod, basically saying neglect the mass of the rod. It rotates, this is a horizontal plane, so gravity is acting into and out of the screen or the page or whatever, okay, point O. I've got some forces that are perpendicular to the rod, 10 newtons at each end, and then I've got a moment applied at the middle of 8t Newton meters. And I want to find the speed 4 seconds later. So speed or velocity, 4 seconds, that tells me impulse momentum. The fact that this thing is rotating tells me angular momentum, which is essentially, looks like this. I can take the sum of all of the r cross mv's, right? So I take r times my momentum, okay, plus any external moments on my system, okay, equals r cross m v final. I guess I didn't do the initial over here, right? So again, I believe it says it starts from rest right here. So this whole thing goes to 0, right? So it's 0 plus, now what are all the moments occurring on this guy? So the first one that I'm looking at is the 10 newtons. And there's two of them, okay? They're creating positive moments, so I'm going to go positive, okay? And they're each 0.5 away times 10, right? So that's r cross f, essentially, 0.5 times 10. And then the time is 4 seconds, right? And because they're constant, and at a constant, they're always perpendicular, I don't have to do any integration or anything. I just take force times time, right? Or I should say moment times time. Then the 2 out front is because I've got 1 on each side. Now, the other thing that I've got is the 8t, okay? This is also a positive moment. However, this one I do need to do integration because it changes as a function of time from 0 up to 4, okay? And what does this equal? Well, again, the only momentum that I have is basically the two balls, right? We're assuming that the rod is essentially massless. So I've got two of those balls, okay? They each have a mass of 10 kilograms, okay? And it's basically RMV, excuse me. I've got 2 times 0.5 times 10, and then their velocity is really what I'm trying to find there, okay? So again, it's 2, because I got 2 of them, RMV, where R is 0.5, M is 10 kilograms, and V is V. So there you go. So calculating this out, that first term becomes 40. The second term becomes essentially 4t squared. So it's going to be 4 times 4 squared. And then that's going to equal 10v. And from that, I can find that the velocity after 4 seconds is 10.4 meters per second. So this is the same as linear momentum. The only difference is rather mv, sum of the linear impulses equals mv2. It's rmv, or r cross mv. And then instead of forces, I use moments times time equals the final rmv, or angular momentum.